so you didn't miss anything.
Okay, perfect.
So I think we have sufficient number of participants. So yeah, take it away, June and Anna.
Okay, cool. So maybe I can start. I guess like so this week we don't have a study topic to share. Maybe we can decide on the next one. But basically, so when we don't have a study topic to share, then it's going to be progress update and any other discussion that we can do. Right. So I guess maybe a quick reminder, just housekeeping stuff. I want to share two things. So right now, most of the work by the Ream team happens in two places, two repos. The first one is the Ream repo under Ream Labs in GitHub. So this is basically our Rust implementation of the client itself. Maybe our team members, our contributors can update on what has happened inside the repo. But yeah, this is where the main stuff is happening. Another one that I want to bring to attention is Ream Study Group. So this one is actually our 8th call now, and all our previous recordings are in here. If we recorded them, and the notes are also in here. Also in this repo is also like general knowledge for anyone who wants to keep up with like all the stuff happening or stuff being shared about the Beam chain. So we have here all the content about the Beam chain proposals. There's also some notes in there. The keynote that Justin shared at DEF CON, at Bankless Summit, at the Defiant, and so on. We also taking notes of all the conversations happen. For example, some concerns by Peter about bundling too many things. There's also discussions that happen in chats that are noteworthy, so we put it in here as well. And we'll be keep updating this study group repo as more information appears. There's also some other subsections, for example, the beacon chain here. So this contains everything that anyone needs to get up to speed about the beacon chain, the specs and all the annotated specs and so on here. And also, pitfalls, lessons learned, all the things that are shared about beacon chain. Recently, Jun also created another subsection that's CKVM. I think we haven't linked to the table of content yet, but inside here we also have more Beam specific CKVM materials that we found on the internet, on the forum, and so on. So, and also like code implementation that we have done so far is also in here. I also added a small section. Oh, sorry, what's cryptography? Sorry. So June added the cryptography page. I added the CKVM pages. But yeah, so all the contents are in here. So basically, all in all, there are two repos that everyone can be watching in terms of Ream development. Then I guess like quick update from me. So I was working on trying to get the state transition function into a CKVM. So I'm working on trying out RISC-0. June worked on SP1 so far. But our initial approach was to try to use Lighthouse Crate and then just plug it into the CKVMs. I think we had a lot of common issues both for RISC-0 and CK for an SP1, but mainly it's RISC-V compatibilities. A lot of the crates or the Lighthouse implementation is not compatible with RISC-V, and a lot of dependencies and sub-dependencies also are not compatible with RISC-V. So we had probably like, for me, it was like 100% hacking Lighthouse instead of using trying out the CKVM. So my general kind of like suggestion, idea right now is probably might be better to start off with the Ream code base and just minimally add the like beacon states in there and do some basic transitions with the CKVM. So that might be I think that would be a better approach than hacking all the dependencies. Maybe Jun, you can share more about like your findings, but basically, yeah, that's my update so far. So I'll continue to work with the Receiver side, and probably try to touch on the state transition function and build them from scratch. And yeah, pass over to Jin.
Oh, yeah, sure. Thank you for a great introduction, though. Yeah, absolutely. Hacking Lighthouse is very difficult because it has so many dependencies that we don't need. So I have taken a lot of time to changing dependencies, like patching things in a cargo toml file. I found that, as O said, we have to build a state transition function from scratch on Ream code base that can we manage our dependencies as minimal as possible. So my first milestone for me is to build the current DNAP beacon chain state transition function on the Ream, and the second milestone is wrapping that into a program that can be run on zkVM. So my approach can uh, um, also be compatible with RISC-0. So yeah, this could work, I think. And also, besides the zkVM things, I also read papers about the hash-based signatures. So I contact with my professor about what is the post-quantum signature and why do we have to use hash-based signature like that. So I studied the few things of hash-based signatures like Sphinx or the Winterness or the XMSS, as Justin mentioned at the paper. So yeah, I'm working at that two things, zkVM and some studying about cryptography.
No, one thing I forgot to mention, and maybe Jin, you can share yours too. But I guess like my challenge so far in working on Ream right now is figuring out like what's the specific like problem statement to work with. For example, like I'm just like trying to plug in the state transition function into CKVM right now, but it's a pretty broad topic, and it's just discovering stuff rather than actually tackling a specific problem statement. So if there's like a venue where we can discuss externally with other teams or researchers as well on what's like the most pressing question about the beam chain, then maybe we can focus on a more specific a problem to tackle. So I guess that would be if something, yeah, that would be helpful. Um, Maybe Jun has something else.
Oh, no.
On the topic of like working with other teams that are kind of going through the effort of integrating with zkVMs, there's this team called Grandine, which I guess you guys know. They have done integrations with SP1 and with Zero, and they've hit a bunch of issues, and they have ongoing discussions with these teams to try and smooth things out. Additionally, they've applied for a grant at the Firm Foundation to take their existing Beacon client and snockify that with the SP1 and with Zero. So if the grant does go through, then I expect them to put in a lot of engineering hours to try and make sure that all of these dependencies issues and all of these tooling issues get smoothed out. So maybe you can learn from them.
Oh,
Do they by any chance?
Do they have any public repo or reference that I can read some things?
Yes. So I have a link here. But what I can do is, I think they also have some stuff that they've done in private repos. So if you want, I can introduce you to the Grantine team or create a group and have them share all their work.
So further to that question, Justin, you were looking to, set up a separate study group for all teams working on Beam, right? Is that being planned anytime soon?
Yes. So I did previously signal that I wanted to do this monthly call at the end of every month. this month was just completely insane for me. I had the sequencing call and whatnot. So my plan is actually to start this month, and I won't start at, probably won't start at the end of the month. I'll start sooner with a group call. But yeah, it's definitely happening. Apologies for the delay.
No worries. And the other question, a more focused group on the P2P stuff that you had earlier discussed or alluded to, especially Li Yang's paper. So is that another thing that you're planning as well?
Yeah, we do have a group with Li.
Oh yeah, I'm part of the group. You added me to it.
Okay, perfect. Yeah, I actually had a call with Li recently. Basically gave him a heads up that I haven't forgotten about him. It was a call about a different topic actually. It was about native rollups, but yeah, at some point the peer-to-peer networking can work and can really start proper. And now we have the foundations with the hash-based paper that was that was published. And if you want, actually, I could just briefly share my screen to show you something real quick, which is, I guess, the most relevant thing for you guys. So, it's a very long paper, 53 pages. The good news is that for developers, like, you can mostly ignore almost all of it. It's largely just cryptographic proofs that are extremely thorough to make sure that we have really strong security. And I think the most important line is the one that I highlighted here. So basically, we have this target sum winterness. That's what TSW stands for, and then W is kind of the window size of 2 bits, and then there's this parameter which basically reflects how much grinding. So one of the optimizations basically is for the signer to do a little bit of proof of work. And, we're talking about hundreds of microseconds of proof of work. So it's a tiny amount of proof of work, but that helps with the verification. And these are like the rough performance metrics that I estimate that we would potentially use. So the signing is extremely fast. It's less than 1 millisecond. The verification is also extremely fast, less than 1 millisecond. The proof size is reasonable, 2.7 kilobytes. And then there's some hashing involved. So here they distinguish 2 types of hashes depending on the permutation size. But broadly speaking, just imagine it's like 1 Poseidon 2 hash for each column. So you just take the sum of these, and it's less than 200 Poseidon hashes. So given that we can do 2 million Poseidon hashes per second on the laptop, and that's proving Poseidon hashes, then we should be able to do 10,000 signatures per second, which is absolutely like mind-blowing kind of fast performance, more than enough than what we need. Now, one thing that I want to highlight as a potential kind of nuisance is the generation time here. So, with XMSS, you have these winternits leaves, and you want to basically pre-generate lots of public keys, winternits public keys. And this is a process that takes a bunch of time. And so here you see for 1 million signatures, 2 to the 20, the generation time is about 600 seconds, which I guess is 10 minutes. Now, this code, I think, is not at all optimized. So, it could be made, it could be parallelized, or it could be optimized in various ways. So I'm hoping that when you join as a validator, you can have, 10 years worth, let's say, of signing, and it would only take a few dozens of minutes to generate the public key. And like, this is a big departure from BLS, where like you can just create your BLS key in an instant. The good news is, I guess, is that because we are going to have max EB, and going to have these large validators up to, actually with the Beam chain, there's going to be no limit. There won't be a 2048 limit. You won't need to generate many keys. It's mostly going to be 1 per operator, or maybe a few per operator. So hopefully that won't be too much of a nuisance. And yeah, another thing that I wanted to share is Peer 2. Another team have started active work on the Beam chain, and they're starting with a C implementation of SSZ, and they are they're calling the client Lantern, partly because they have an existing light client called Lantern, but also because their team project was started at DEF CON in Thailand, and so Lantern is kind of a good nod to that. And yeah, I think that's pretty much all the updates that I have. Oh no, I do have one more update. So today we are going to be launching ethproofs.org. So there's going to be a big announcement on Twitter. We have 3 different launch partners. Let me show you real quick because it's quite fun. So if you right now we have a preview, but we'll remove this in a few hours. So if you click preview, which you won't have to do soon, it loads the website, and you can see. So for example, we're limiting ourselves to blocks that end in 00, so 1 in every 100 EVM mainnet blocks. And so this is a good block here because there's 3 different provers that have generated proofs. So if we go and dive in, you can see the 3 provers. We have Snarkify, Succinct, and ZKM. And like one thing which I find kind of mind-blowing is that the proofs are just so dirt cheap to generate. So it's like 7 cents for a proof here. And this is going to go down quite significantly. So it could well be like 1 cent for a mainnet EVM block by the end of this year. And you can download the proof. It tells you how big it is here. And if you click on the chip icon here, it will tell you like which machine is capable of doing this, the proving. So these are AWS machines, and so we can fetch the hourly price. So a machine that costs 90 cents per hour was able to generate this proof, and it tells you the details of the machine. Here you have the number of ZKVM cycles. So every different ZKVM vendor has a different notion of cycle, and so this is why even though it's the same block, there's different cycles. And then the proving time. So Snarkify has achieved a 4-minute proving time, which is really, really cool. And this is on single machines only. So right now, just for fairness and for simplicity, we've limited ourselves to single machine. But once we allow multiple machines and like GPU clusters, these proving times are going to go way down. And the aim of ethproofs, I guess, is to try and encourage real-time proving within 12 seconds, which I'm like pretty confident that by the end of this year we'll have multiple vendors doing that. So right now we only have these 3 vendors that have integrated, but we're talking with a dozen other vendors, which hopefully will be integrated over the next few months. And yeah, one side note is that this is a project that was incubated within the Ethereum Foundation. But what we're hoping to do is community members to just take responsibility for the project and ownership of the project, similar to what's happening with L2Beat, where maybe the Ethereum Foundation can support the website with a grant, but ultimately it would be people outside of the Ethereum Foundation driving the development. And that's it from me. Actually, I do have like maybe one relevant update, which is, recently I had this ETH research post on native rollups, and it's very synergistic with the Beam chain because it uses the same technology. It has the same requirements around ZKVM diversity and performance and things like that, and security. And there was this call on Friday where multiple founders from rollup projects came to basically signal their interest in native rollup. So, for example, you had Ben from Optimism, you had Jesse from Base. There was Nick from Namechain. Hayden is also very excited. Hayden from Unichain is also very excited about native rollup. So hopefully, all of this parallel effort with the native rollups will help accelerate the timelines on the Beam chain.
Actually, Justin, I have one question on that actually in the chat that for the native rollups, are you anticipating any big changes to the CL? Because I understand that mostly the native rollup is around the execute precompile and maybe like the way you generate multi-proofs and verify the multi-proofs is related. But I wonder in terms of like specs or behavioral wise on the CL, are you anticipating any changes?
Nope, not really. Like these are like very cleanly decoupled layers of the stack, and I don't really foresee changes. What I do foresee is that the operators that are currently running ELs will have the option to run a ZK EL client, which will verify the proofs. But then ultimately, there's going to be the same engine API, and is from the point of view of the CL, there's no changes.
I can give an update next if everyone's done. Short update on the core Ream repository. So we've implemented most of the phase 0 functions. So we'll move on to the next part soon. And since June and Una would need the state transition function directly from Ream due to the inherent issues in Lighthouse. So we'll work together on implementing this STF directly in Ream and then plug in the ZKVM on top of that next. So yeah, that's a short update for Ream core. Also, quick question to Justin. So I've gone through the native rollup post that you made last week. I was wondering if everyone's interested and if you have the time for it, maybe you could take a session on that at one of our study sessions. Maybe not next week, whenever you're available to take a session on that. Although you said it doesn't affect the CL much, but it would be a nice introduction to how things are going to change.
Yeah, absolutely happy to do that. I will be I'm probably going to be speaking about native rollups in various venues, so I should have some slides ready in a few weeks.
Okay, I think that's probably all the updates. Does anyone else
Actually,
have?
I do have like one more update, which is that I'm actively working to onboard some coordinators that will help. They'll help us within the EF research team. We've onboarded. Well, so there's this person called Ladislaus, who's I think his first day will be. I don't want to say something silly, but it might be the 1st of February or maybe the 1st of March. I need to go check. But in any case, he should be joining relatively quickly. And once he's fully officially onboarded, then I'll introduce you to him. And I'm also looking to onboard another coordinator in the pipeline. So hopefully, I won't be the bottleneck as much as I am today in a couple of weeks.
Also, Justin, I just had a small query that all these proposals that are being made on execution tickets and APS and Fossil, I was just trying to understand how all of this is going to fit into the beam chain. Is there a write-up or something so that I can, direct myself to what is going on?
Yeah, so there's going to be like some things that will be done incrementally, like Fossil, that needs to be done as quickly as possible. APS is kind of a tricky one because it's like relatively ambitious, but maybe like doable before the beam chain. Hopefully, it is doable before the beam chain. There is a new website. It's called aps.directory. Let me share it in the chat. Yeah, I'm not sure what's wrong with the DNS, but like sometimes it works, sometimes it doesn't work. In any case, there's basically Julian who's leading this effort, focusing, I think, most of his time on APS in 2025, and I'm hoping that an output from him, in the next few months, is that we have some sort of a concrete EIP, and that we make a decision as a research team on exactly which direction we want to go down with APS, because it turns out there's a dozen or so different things that we can tweak with APS, and like 2 to the power 10 is about a 1,000 different designs. So we want to try and narrow exactly the design space so that we can pick something. And like one possible way to think about APS in the context of the beacon chain is that maybe we can try and find something which is good enough so that we can start getting experience and market data, and then with the beam chain potentially revisit whatever design we have and try and build something as close to ideal as possible.
Understood. Yeah.
Okay, I guess if there's nothing else, then I think we can conclude this call. Oh, actually, one more thing. So the study group topic, the sharing topic for next week, I think we haven't picked one yet. Just wondering if there's anything anyone would like to share with the team next week, perhaps. So if not for now, I think the slot is still open. So if anyone is interested, got anything interesting to share, I think feel free to keep chatting in the Ream team Telegram group. Yeah, I think that concludes it. So thank you everyone for joining. I think the recording, Partha will have it up, and then we'll have we'll post the notes into the repo as well. Partha, do you have anything to add?
Sure. No, actually, sorry, I was held up because there was an engineer visiting and I couldn't speak. I didn't have anything else to add, so I'll share the recording as soon as it's ready.
Oh, okay. I think that's it. Thank you everyone for joining.
Cheers. Thanks. Bye.
See you guys.
Thanks. Bye.
Bye.